Welcome back to this class. Let's see how we can compute resultant of vectors that are inclined at any other angle other than 90 degrees. So inclined vectors at any other angle other than 90 degrees. Let's say the angle between them is equal to theta. Say angle equal to theta. Now, let's say we have a line of force. So this is, let's say we have a box. If this is a box being pushed by a man to this direction, let's call this F1, and another man is pushing the same box to this direction, let's call this F2. So we see that the two converge at a point. They converge here. So what we are going to do in this case, the angle between them is theta degree. So we are applying parallelograms law. So if we apply parallelograms law, by applying that, we have to complete this parallelogram. Let me redraw this very well and remove the box. I only need the vector line, the line of force only. Let's say this is F1 and then this is F2. So, and there is angle theta between them. So I have to complete this parallelogram in every case. So if this line and this line are parallel to each other, if this is F2, then here too will also be F2. Then I will complete this as well. If this is F1, here too will be F1. Now at the end of the day, this is the point of action. We're now having a complete parallelogram. This is a complete parallelogram. And from the point of action, I will draw my resultant diagonal. If you draw the diagonal from here, this is not the point of action of the two forces. So the resultant must always come from here. So we have our resultant here. Now here, if this is theta, it has been proven that here too will be 180 minus theta. 180 minus theta, because by extending this line, here will give us theta as well. So, because if this is theta, here too will be theta by corresponding angle. These two angles are corresponding to each other. So, and this is a straight line. This is theta. The remaining angle here will be 180 minus theta. That's how we have it. Now, to find the resultant, we already have a formula for that. R squared will be equal to F1 squared plus F2 squared plus 2F1 F2 cos theta. This is one way of using the formula. Then, or we can use it as R squared is equal to F1 squared plus F2 squared minus 2F1 F2 cos 180 minus theta. So these two, if we apply any one of the two, we get the same answer. This is the formula for finding resultant in this case. Now, the other thing that remains is how do we compute our direction? We can find, let's put angle alpha here, and then we put angle beta here. Now, if we draw 4 cardinal points for this, north will come in this direction, and then south will come like this. This is north. Then west will come like this, and this vector line represents the east. So I need the remaining angle, the angle from here, from the north to where my resultant is. Not actually alpha, but I will need to first get alpha before I get this. Now, if this is alpha, let me call this one angle Z. Let's call this angle. Okay, any angle. If this is alpha, beta, let's call this one gamma. Let's call this gamma. Now, and we know that both gamma and alpha are making 90 degrees. Yeah, because they are mutually perpendicular. They are perpendicular to each other. Now, alpha and and gamma, they are 90 degrees. They make up 90. They are complementary. So once I get alpha, I can get gamma. That will just be 90 minus alpha. That will give me gamma. So from here, what I will just do is to use sine rule. This formula that we have here is cosine rule, and I will later show how this is derived. So, but not in this video. Now, how do we find alpha? We can say f1 all over the angle it is facing, sine of the angle it is facing, all over f2 equal to, we have f2 here, f2 over sine of the angle it is facing equal to r all over sine of the angle it is facing. So let's do that. f1 all over sine of the angle it is facing, that's sine alpha, equal to f2 all over sine beta equal to r is the f3, r all over sine 180 minus theta. So if we can work this out to get alpha, then we can know our beta. We can just use f1 all over sine alpha in relation to this, because this will be complete known terms. R is known, 180 minus theta is also known, but the f1 is known, sine alpha is unknown. We compute. So I will solve example in subsequent video. Once we can get alpha, gamma will be gotten by 90 minus alpha will give us gamma. So the complete representation of the vector will now be the complete representation of the resultant will now be resultant equal to r, whatever we get for r, Newton, in the direction north, gamma degree east. This is gamma degree east, depending on where the resultant is falling. It may fall here, it may fall here, it may fall here. It depends. So thank you for viewing this. In subsequent video, we'll be solving examples.